Okay, this is the last page, or I mean, the last part of the video. This was the last page we talked about, though, but I think I got cut off. So, what I was trying to say was when you have mutually exclusive events, they cannot happen at the same time, which means there's no overlap. So, basically, you take this formula, but there's no overlap. So, the formula is just adding the two probabilities together. That's only when there's no overlap. Okay. And no overlap is mutually exclusive. Okay. All right, moving on. Um, we did an example using this a couple days ago. Sometimes it's better to think of like the opposite. Um, like if you want the probability that something will not occur, this is the probability that something will not happen. You could think of it as 1 minus the probability of it happening. One being 100%. So like if the probability that it's not going to rain is 20%, then wouldn't the probability of it raining be 80%? If that makes sense. Um, okay, so what's the probability of not drawing a jack? Probability of not drawing a jack. Well, I mean, we could sit there and figure out, okay, what's the probability of drawing an ace? What's the probability of drawing a 2? What's the probability of drawing a 3? What's the probability of drawing a 4? And so on. Well, it's much easier to do 1 minus the probability of a jack. That would be the opposite, right? So, and we already figured out the probability of a jack, oops, I don't want an equal sign there. The probability of a jack, how many jacks are there in a deck? There's 4 jacks out of 52. So if we do 1 minus 4 out of 52, we get 12 out of 13, which doesn't that make sense? There was only one jack for every 13 cards in a suit, so the other cards that are not jacks are 12, the other 12 out of the 13 for each suit. Okay. All right. So we're just going to do a random assortment of examples. And with probability as well, there's lots of different ways to do the problem. So the way that I'm showing you now is not necessarily the only way. Um, so if you ever want to check and see if your way works as well, just let me know. Okay, 10 people apply for 2 jobs. 4 are women and 6 are men. What's the probability that both people hired are men? So we need to find the probability that the first person is a man, and we need to find the probability that the second person is a man. And did you hear in my voice when I said the probability that the first is a man and the probability that the second is a man? Okay, a couple slides ago, what did we do when it was an and? Did we multiply or add? We multiplied. Okay, so the probability that the first person is a man, well, there's 6 men out of 10 people. 6 out of 10. Okay, now we've chosen a man. Okay, how many men are left? 5 men are left. How many people are left? 9 people are left. So you multiply those together and you get 1/3, or we could say 33.33%. Okay, the probability that both are women. So that would be the probability that the first person is a woman, and so multiply the probability that the second is a woman. Okay, the first being a woman Well, there's 4 women out of 10. And the second woman, well, assuming this is a woman, because we've picked a woman, there's only 3 women left, and there's only 9 people left. So multiply those together, and we get 2 out of 15, which is 13.33%. Okay, now the next one is the probability that 1 man and 1 woman are hired. Okay, now this gets a little bit more complicated because I don't know if the man is first or the woman is first. But we could find the probability of choosing a man, and we could find the probability of choosing a woman. Okay, so the probability of choosing a man, there's 6 men out of 10. Probability of choosing a woman, there's 4 women out of, be careful, it's not 10. This person's already been chosen, so there's only 9 people left. Okay, but now to account for the fact that I could have done a woman first and a man second, let's multiply that by 2 for the different arrangements that we could have had. And we get 53.33%. You know how I said that there's always more than one way to do this? Here's another way to think of this problem. We have 4 women and we're going to choose 1. And we've got 6 men and we're going to choose 1. Okay, and then how many total possible combinations of 2 people are there? That would be 10 choose 2. There's that many combinations or ways to choose 2 people from 10. So that way would also work. Okay. Keeping going with that same problem, what if what if we're trying to find the probability that at least 1 woman is hired? So the probability of at least 1 woman. So it could be 1 woman or 2 women. Well, thinking of it separate like that can be a little bit more complicated. So what you might want to do is apply that concept on this page, where we can do 1 minus the opposite. So what's the opposite of at least 1 woman? The opposite of at least 1 would be none. So the probability that none are women, well, if none of the 2 people are women, then wouldn't that have to be that 2 of them are men? And we already found the probability that 2 are men. Let's go back. Here's the probability that 2 are men, 1/3. Okay, so that means that the probability of choosing at least 1 woman is 2/3, or we could say that that's 66.67%. Okay, this next one is a little bit more tricky. 8 cards are drawn from a standard 52 card deck with replacement. That's big. With replacement means you draw a card and then you put it back in. So you draw a card, when you put it back in, the deck is the exact same as it was the first time. So make sure that that you read things carefully, because with replacement is way different than without replacement. Okay, so then what's the probability that at least 1 is a king? Okay, so then theoretically, couldn't we have 1 king or 2 kings or 3 kings or 4 kings or 5 kings or 6 kings? You know, and so on. Actually, Hang on just a second. Okay, I had to pause it there for a second. I'm actually going to come back to this problem when I'm with you in person because it's going to take a little bit more of an explanation and I'm starting to run out of time on this video. So I'm going to skip this temporarily and we will come back to it when I see you next. So go on to the next page because I want to get through more examples. Okay, let's do, I'm just looking for what would be good. Okay, let's do this one. 2 fair 6-sided dice are rolled. What's the probability that the sum of the numbers is a 7? Okay, now, how many different ways are there to roll the first dice? There's 6. How many different ways are there to roll the second dice? 6. That means there's a total of 36 possible outcomes. So just keep that in mind. Okay, we need to have a sum of 7. So I could have a 1 and a 6. I could have a 6 and a 1. I could have a 2 and a 5 or a 5 and a 2. I could have a 3 and a 4 or a 4 and a 3, right? So that's 1, 2, 3, 4, 5, 6 possible ways to get a sum of 7. So that would be 6 out of the 36 total, which is 1/6. That would be your answer. Down here, what's the probability of not a 7? I could do that whole concept of the opposite. I could do 1 minus the probability that the sum is 7. That's a P. Okay, so I could do 1 minus the probability that I do get a 7. Well, we just figured that out. It's 1/6. 1 minus 1/6 would be 5/6. So does that make sense? If the probability that the sum is 7 is 1 out of 6, then not a 7 would be the other 5 out of 6. Okay, for the sake of time, I'm going to skip a few things. Okay, here's that classic like marbles in a bag. Okay. We have 1 yellow, 2 green, 3 blue, and 4 red marbles. We're going to draw 2 without replacement. That's, again, that's big. Without replacement, that means we're going to draw 1, but we're not going to put it back in and draw another. That's a bigger deal than you might think. Okay, so we're going to find the probability of drawing 2 reds. So what's the probability of your first one being a red? Well, there's 4 reds out of, what's our total? How many total? 1 plus 2 plus 3 plus 4 is a total of 10, right? Okay, so the probability of drawing a red is 4 out of 10. Okay, now that is a red that's been drawn. How many reds are left? Only 3 reds are left, and there's only 9 marbles left in the bag or whatever we have. Multiplying those two together, we get 2 out of 15. Okay, let's see. The probability of drawing 1 green on the first draw and 1 blue on the second draw. So what's the probability of drawing a green? There's 2 greens out of 10. And, see, we multiply. 1 blue, okay, so there's 3 blues in the bag, right? But we already drew a marble out, so there's only 9 marbles left. So multiplying those together, we get 1 out of 15. And, oh, I'm running out of time. What's the probability of drawing 2 yellows? Well, I only have 1 yellow, so 0. Can't happen. Okay, so there's more that I want to go over, but I think this is enough to get you started, and then when I see you in class next, we'll go over lots of questions, okay? Just do the best you can on your homework. You have the rest of the time of the hour to work. Be good for the sub. Okay, bye.